Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the dew point measurement uses the cloud chamber, the lithium chloride cell, the polymer sensor, the condensation system on a mirror, and the infrared analyzer. The cloud chamber performs a discontinuous manual dew point measurement. It consists of a small chamber with a manual pump that allows compressing a gas sample. The operator notes the initial pressure and temperature of the gas and compresses it to a given pressure. Next, opens an escape valve to the atmosphere, whereby the gas undergoes an adiabatic expansion and decreases its temperature. The test is repeated several times, compressing the gas more and more until the temperature reached in the expansion causes fog to appear in the chamber. This temperature corresponds to the dew point. The lithium chloride cell consists of a cloth sleeve impregnated with a lithium chloride solution, wrapping around a coil. On the sleeve is wound a bifilar wire open at one end and fed through the secondary of a transformer, whereby a current flows between the wires to the lithium chloride salt. It has the characteristic property of maintaining a relative humidity of 11% in equilibrium with the humid atmosphere. At values lower than 11%, the salt crystallizes and is no longer conductive. Salt is highly hygroscopic, which is why it has a great affinity for ambient humidity. The higher this is, the more conductive the salt will be, and the more the coil will be heated by the flow of current through the bifilar wire. The equilibrium temperature of the coil is thus related to the dew point of the air or gas, so that it can be measured with a resistance probe and a Wheatstone bridge instrument graduated directly at the dew point temperature. The cell is suitable for ambient temperatures from -30 to 130 Celsius degrees. At temperatures above 130 Celsius degrees, the dew point can be measured by admitting air to a constant temperature chamber and cooling it to less than 80 Celsius or 180 Fahrenheit before circulating to the cell. The cell requires that the gases whose dew point is measured do not contain ammonia, sulfur dioxide, chlorine, salt, or suspended particles. In case the cell becomes contaminated, it needs to be regenerated by cleaning it and immersing it in a lithium chloride solution. Its use has been decreasing due to these maintenance problems and not being able to measure dew point values lower than 11%. The polymeric sensor used in the measurement of humidity also allows to determine the dew point. In the instrument's memory, there are humidity sensor response tables that allow the microprocessor to evaluate the digital signals corresponding to the temperature and humidity of the sensor, and thus determine the dew point of the atmosphere where the sensor is located. Here, we can see the accuracy of the instrument for two types of probes. The compensation system in a mirror consists of a chamber with a heating and cooling system that controls the temperature of the surface of a mirror located inside, and through which a current of gas circulates whose dew point must be determined. A photoelectric cell acts on the cooling or heating system to achieve constant fogging of the specular surface. The temperature of this surface indicates the dew point of the gas. The instrument has a total accuracy of ±0.2 Celsius and repeatability of ±0.05 Celsius for dew points between 60 and 85 Celsius. The infrared analyzer can not only measure the dew point of water vapor, but also any of several constituents, such as those you see in the screen. The infrared analyzer consists of a pulsating infrared source, nickel chrome filaments, two cells, one of reference and the other for samples through which the infrared radiation passes, and a detector. If the detector chamber is filled with water vapor, infrared radiation is absorbed proportionally to the water vapor concentration in the sample gas cell, thereby decreasing the pressure in this chamber as a result of the intermediate energy absorbed. If the two radiations are blocked, one that passes through the reference cell and the other that passes through the gas sample cell to be analyzed, there is no pressure variation in the chamber. If the reference cell contains an unabsorbent gas, such as nitrogen, and the wet gas passes to the sample cell, radiation to the sample gas will be attenuated at the wavelength of the water vapor in the gas, while radiation to the span gas, N2, will remain unchanged. A pulsating variable pressure is thus obtained in the detector. It contains two chambers separated by a diaphragm that acts like a condenser microphone and converts the pressure pulses to an electrical signal that is amplified, rectified, and finally recorded. The instrument, in addition to measuring the dew point, can determine the percentages of various components in the gas to be analyzed. Infrared analyzers are quick response, suitable for recording various gas samples. They can analyze atmospheres containing ammonia, and with the help of standard cylinders are difficult to calibrate. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!